Hey everyone, glad you could join us today. We are diving into one of the most mind-bending mysteries the universe has ever offered: wormholes. Those strange cosmic tunnels that might just bend the very fabric of reality itself, connecting distant corners of space and time as if the universe were folding in on itself, like paper meeting paper. A bridge through the impossible, a shortcut through infinity. But before we let curiosity pull us through, take a deep breath, let your mind drift, and imagine what it would feel like to step near one. To see the stars stretching and bending around a swirl of light so deep that even time begins to twist upon itself. Now let's relax, settle in, and enjoy this journey together. Because what we're about to explore may sound like science fiction, but it's also one of the most serious questions physicists have ever asked. Can the universe really allow shortcuts through space and time? Could there be hidden doors scattered among the galaxies, invisible to our eyes but waiting to be found? Or are they just the mathematical dreams of a universe that loves to play with imagination as much as gravity? A wormhole, in theory, is a tunnel connecting two points in space-time. Imagine space as a giant sheet, and if you fold that sheet so that two distant points touch, a wormhole would be the bridge between them. It's an idea that came to life from the equations of Albert Einstein and Nathan Rosen back in the early 20th century. Their calculations suggested that gravity could curve space so intensely that it might create tunnels. Now, these Einstein-Rosen bridges, as they're sometimes called, might be microscopic, smaller than an atom, or they could stretch across galaxies, connecting the most distant stars in a single instant. If you were floating near one, you might see the stars warp and twist, light bending into ribbons, time slowing down, colors stretching into strange shades. And even though it feels impossible, the math says it's not entirely forbidden. But there's a catch. Most wormholes, if they do exist, might collapse before anything could pass through them. Like a soap bubble popping the moment you touch it, the gravity would be too strong, the structure too unstable. Without something called exotic matter, a mysterious substance that seems to defy gravity and hold space open, these tunnels wouldn't last more than a blink. Scientists have tried to imagine what would happen if we could stabilize one. Perhaps one day we might step through and emerge light years away, crossing galaxies in seconds, or maybe even traveling through time itself. The concept of time travel is tangled up with wormholes. If one end of the tunnel moves at a different speed through time than the other, then stepping through could take you not only across space but also into another moment, maybe to the distant past or the far future. Imagine drifting near a black hole, watching its lightless mouth swallow stars, and somewhere beyond its event horizon lies a tunnel, a hidden passage that leads somewhere else entirely. Some believe black holes might even be the entrances to wormholes, with white holes on the other side. White holes would be objects that expel matter instead of consuming it. No one has ever seen one, but the theory suggests that if they exist, they might connect different parts of the universe, or even different universes entirely. Now take a moment, look up at the night sky in your mind, and imagine every star you see as a doorway. Somewhere out there, hidden among the galaxies, one of them could lead to a place beyond comprehension. A place where light bends back on itself, where time folds, and where the familiar laws of reality begin to blur into something new. The thought of traveling through a wormhole sparks both wonder and fear. What would happen to your body, to your atoms, if you entered one? Would you stretch like light or dissolve into energy? Would you come out the same on the other side? Or would time have passed so differently that everything you once knew had changed? For now, wormholes remain only in theory. We've never observed one directly. No telescope has spotted a cosmic tunnel. No spacecraft has drifted through one and sent back a message. But physicists continue to search. They look for signs in the bending of starlight, in the movements of galaxies, and in the faint ripples of gravitational waves that echo through the cosmos, hoping one day we might find proof that these shortcuts through space-time truly exist. So, as you let your thoughts wander, think about what it means for the universe to hold secrets like this. That space itself might be more flexible than we can imagine. That maybe, somewhere out there, 2 points that should be light years apart are secretly touching, connected by a cosmic bridge no one has yet seen. Passing through a wormhole could feel at once instant and infinite, a paradox that challenges our understanding of space, time, and consciousness. Because a wormhole is not merely a passage through distance, but a tunnel through the very fabric of space-time itself, a bridge between points that might be separated by billions of light years or even entirely different universes. The sensation of traversing such a structure would not resemble any earthly experience, not flight, not freefall, not even floating through the void of space, because it involves moving along dimensions of reality that our senses and minds are not equipped to comprehend in ordinary terms. The passage might feel instantaneous in one sense, as the spatial distance from entrance to exit could be crossed without the familiar progression of steps or miles. Yet it could simultaneously feel infinite, because time, perception, and spatial geometry could warp, stretch, and fold in ways that seem to suspend or multiply every moment. Imagine stepping into the mouth of a wormhole. At first, the sensation might resemble entering a tunnel, a corridor framed by impossibly bending light and shadows, but immediately, the normal rules of space dissolve. Directions twist, up and down lose meaning, and distances that once seemed vast collapse into something tangible yet indescribable. You may feel accelerated and yet stationary, moving through what seems like an eternity of space while your body experiences only a heartbeat of real time. The curvature of space-time inside the wormhole could create loops, spirals, and folds, so that your mind perceives multiple paths simultaneously, each a distorted echo of the journey, giving the sensation that the passage is endless while also instant. Time itself might behave strangely. General relativity predicts that in extreme gravitational and spatial curvature, time dilates. Within a wormhole, time at the exit could flow faster or slower relative to the entrance, meaning a traveler might emerge moments after entering from one perspective, yet ages, events, or light from the outside could suggest a far longer or shorter journey. This temporal distortion would make the experience feel both instantaneous and eternal, as if the very clock of the universe is bending to accommodate the unusual geometry of the tunnel. Moments could stretch, collapse, or overlap, producing a sensation akin to standing inside eternity while simultaneously taking a single breath. Sensory perception might also be radically altered. Light entering the wormhole could refract, bend, and warp, creating shifting panoramas of colors, stars, galaxies, and cosmic phenomena layered over one another. You might perceive entire nebulae twisting around your body, streams of photons folding like ribbons, or stars appearing and disappearing in ways that defy ordinary spatial logic. The visual experience alone could create a feeling of infinite complexity, an endless cascade of information processed instantaneously by the mind, blurring the distinction between vastness and immediacy. Physical sensations might follow suit. Tidal forces could stretch or compress the body along unusual axes, though in a stable wormhole, exotic matter would mitigate destructive effects. You might feel elongated, flattened, or twisted, but in a way that does not harm, producing an uncanny sense of movement that is both instantaneous and unending. Even vibrations in space-time might be perceivable as subtle hums or resonances, a faint pulse of the cosmic fabric itself that seems both fleeting and eternal, carrying a sense of motion through an infinite tunnel of reality. Emotionally, the journey could feel profound. There could be awe at the incomprehensible scale of the experience, fear at the unknown, exhilaration at the sensation of traversing impossible distances, and a simultaneous sense of timelessness. The mind might attempt to reconcile the paradox of instant arrival with infinite passage, producing a feeling that each second is expanded into eternity, while the entire journey is compressed into a single instant of consciousness. Furthermore, if the wormhole connects regions of space where physical laws differ slightly, the passage could feel even stranger. Light, gravity, and even quantum fluctuations might behave unpredictably, amplifying the sensation of infinity. A photon might curve and loop around the tunnel walls, producing endless flashes and reflections, while gravitational distortions stretch moments into incomprehensible spans. You might feel motion that is both instantaneous and extended, a paradoxical overlap where distance and time lose meaning. Yet each microsecond of perception is filled with infinite detail. Travel through multiple wormholes could amplify this effect. Entering one wormhole might feel instant yet infinite, and emerging into another could create nested layers of perception. A recursive journey through realities where each passage folds space and time in ways that multiply the sensation of infinity while maintaining an instantaneity of arrival. Consciousness could perceive an endless series of possibilities, paths, and geometries simultaneously, producing a sensation of being everywhere and nowhere at once. A timeless traveler moving through both the microcosmic and macrocosmic scales of the universe in a single, continuous experience. In essence, passing through a wormhole is a journey where ordinary distinctions between instant and infinite break down. The entrance may seem immediate, yet the mind experiences the stretching, folding, and spiraling of space-time as eternal. Distances collapse, time dilates, senses are overwhelmed by shifting light and energy, and consciousness is stretched across the geometry of the tunnel itself. The paradox is fundamental. A traveler could emerge at the exit in what seems like a moment, yet feel as though they have passed through infinity, experiencing a journey that is both instantaneous and eternal, both microcosmic and cosmic, both a single breath and an eternity simultaneously. Could wormholes exist right now, invisible to every telescope on Earth, is a question that takes us to the edge of what is known, blending physics, imagination, and the mysterious nature of the universe into one almost incomprehensibly vast possibility. Wormholes, as theorized by Einstein and Rosen, are tunnels through the fabric of space-time, potential shortcuts connecting distant regions of the cosmos. The very concept is mind-bending, a solution to equations that describe how mass and energy warp space and time. But the question of their hidden existence, right now, undetectable by any instrument we have, opens a doorway to profound cosmic speculation and subtle physical possibility. First, consider what it means for something to be invisible. Telescopes detect light, radio waves, X-rays, gamma rays, infrared, and other forms of electromagnetic radiation. They capture the energy that matter emits, reflects, or absorbs. Wormholes, if they exist, may not emit or interact with ordinary matter in any visible way. Their surfaces, if they have surfaces at all, could be composed of exotic matter with negative energy density, matter that has never been observed directly and may not interact with light as ordinary matter does. A wormhole could be entirely transparent to photons, bending space without bending the path of light in ways our instruments can currently measure, leaving no signature detectable from Earth. Next, think about scale. Wormholes could be microscopic, subatomic tunnels that exist for infinitesimal durations before collapsing, too small and fleeting to be observed. They could also be large enough to transport stars or spaceships, yet their entrances might be hidden in regions we cannot easily observe, deep within the dense cores of star clusters, near black holes whose extreme gravity already bends light. or in interstellar voids where very little matter exists to interact with light. The universe is vast, filled with regions we cannot directly probe, and a wormhole could exist in one of these unseen pockets, entirely hidden from our current surveys of the sky. The dynamics of space-time itself also play a role. A wormhole may warp light around it subtly, but if it is small, distant, or aligned in a certain way, these distortions might fall below the sensitivity of our instruments. Gravitational lensing, the bending of light by massive objects, can reveal the presence of unseen matter, like dark matter. Yet a wormhole composed of exotic matter might interact differently with space-time, producing distortions that are too slight, too fleeting, or too complex for us to distinguish from ordinary gravitational effects. In this way, wormholes could exist in plain sight yet remain completely invisible, hidden by the very physics that allow them to exist. The universe is full of extreme environments that could host such hidden structures. Around black holes, space-time is already stretched to extremes. Near neutron stars, magnetic fields trillions of times stronger than Earth's distort the paths of charged particles. Within the dense clouds of gas and dust, light struggles to escape, and regions of high mass can bend space in ways that could obscure a wormhole entrance. Across billions of light-years, galaxies drift and clusters collide, creating turbulence in space-time itself. In this complex, dynamic landscape, a wormhole could exist unnoticed, its presence masked by the natural chaos of the cosmos. Even the passage of time complicates detection. A wormhole might be transient, forming and collapsing on timescales of milliseconds, years, or millennia. A telescope pointed at the right spot at the right moment might see nothing, while moments earlier or later, the wormhole could have existed, a fleeting bridge through space. The universe itself is in motion, galaxies rotate, stars orbit, cosmic structures shift, and any hidden wormhole might be moving, evolving, or oscillating, further evading observation. Its invisibility is not just about light, but about the imperceptible dance of space-time and gravity that surrounds it. From a theoretical standpoint, wormholes require exotic matter to remain open, and such matter may interact with the universe in subtle ways. Negative energy, if it exists, could prevent collapse but may produce no detectable signal in ordinary photons or particles. The wormhole could be a conduit, invisible and silent, connecting two distant points without revealing itself in any conventional sense. Its entrances could be surrounded by normal matter that reflects no unusual light, its presence inferred only by extremely subtle gravitational anomalies, ripples in space-time, or the unexpected trajectory of particles passing nearby. The implications are staggering. If hidden wormholes exist in the Milky Way or beyond, they could connect regions of space we think are impossibly distant, allowing matter or information to travel along routes we cannot perceive. They might influence the evolution of stars, the formation of clusters, or the motion of interstellar gas without leaving any detectable footprint. Entire processes in the universe could be subtly guided by structures we cannot see, hidden highways threading through the cosmic fabric, invisible yet shaping reality on scales both local and galactic. Even our attempts to detect wormholes are limited by the tools we possess. Gravitational wave observatories, designed to detect ripples from colliding black holes and neutron stars, may someday sense subtle distortions hinting at a hidden wormhole. High-energy particle detectors could pick up anomalies in cosmic rays that suggest unusual space-time shortcuts. But current instruments, limited in sensitivity and scope, might simply be blind to the very phenomena we seek, allowing wormholes to exist undetected, unnoticed, and untouched by human observation. Philosophically, the possibility reshapes our understanding of reality. The universe we perceive, the stars, galaxies, light, and dark matter, is only part of the story. Hidden wormholes suggest a layer of cosmic architecture entirely invisible, a secret network threading the cosmos, influencing events without our awareness. Space may be more connected than it appears, not only through gravity and light, but through hidden corridors that defy ordinary observation, pathways that could in principle allow instant travel across unimaginable distances. Ultimately, could wormholes exist right now, invisible to every telescope on Earth? The answer is yes. Theoretically, they could. The laws of physics allow for it. The universe contains the conditions that could support it, and our instruments may simply be insufficient to detect them. They could be microscopic or massive, fleeting or stable, hidden in voids or cloaked by black holes, interacting with light and matter in ways we cannot yet measure. The Milky Way, the entire observable universe, might be threaded with invisible tunnels, silent bridges through space-time, secret pathways that exist beyond perception yet shape reality in ways we are only beginning to imagine. Could wormholes exist inside black holes is one of the most intriguing, mind-bending, and speculative questions in modern physics. Combining the extreme mysteries of black holes with the theoretical possibilities of space-time tunnels, and it stretches our imagination to the very limits of understanding. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape once it passes the event horizon, the boundary that separates the interior from the observable universe. They warp space-time to an extraordinary degree, stretching and compressing dimensions in ways that defy ordinary comprehension. Wormholes, on the other hand, are hypothetical passages through space-time, tunnels connecting distant points in the universe or potentially even different universes entirely. To consider the possibility that wormholes might exist inside black holes is to imagine a hidden architecture within one of the most extreme objects in the cosmos, a secret passageway embedded in the heart of a region where the known laws of physics are already pushed to their limits. Inside a black hole, the curvature of space-time becomes extreme as one approaches the singularity, a point where density and gravity theoretically become infinite, and classical physics breaks down. It is within this extreme environment that wormholes might, in theory, find a foothold. The intense warping of space-time could create conditions suitable for the formation of a tunnel, a shortcut through the fabric of reality that threads through the black hole, connecting one distant region of space to another, or even opening into a separate universe. The very forces that threaten to crush everything into a singularity could paradoxically stabilize the entrance to a wormhole, provided the presence of exotic matter with negative energy density, which could counteract the gravitational collapse and keep the passage open. The experience of being inside such a structure is almost impossible to imagine. As one approaches the black hole, time slows relative to distant observers due to gravitational time dilation, and space itself stretches and compresses. The event horizon marks the point of no return. Yet a wormhole entrance inside could bypass the normal rules, providing a hidden path where the laws of causality, distance, and motion are radically different. Entering a black hole might feel like entering a tunnel of impossibly twisted light and gravity, where directions curve, distances collapse, and the familiar sense of up and down ceases to exist. The interior of the black hole would not be merely dark. It could be filled with warped and refracted light, gravitational waves, and quantum fluctuations interacting in complex ways, creating a visual and physical landscape unlike anything else in the universe. The physics required for such wormholes is extreme. Exotic matter with negative energy could hold the tunnel open, counteracting the inward pull of the black hole. The geometry of space-time would have to be precisely tuned, a delicate balance between collapse and stability, creating a corridor that threads through the singularity or avoids it entirely, allowing matter or information to traverse without destruction. Quantum effects, which dominate at very small scales, could also play a role, creating fluctuations that temporarily stabilize or destabilize the tunnel, producing a dynamic, living structure hidden within the black hole's interior. If such wormholes exist, their entrances might be hidden and undetectable from outside the black hole. The extreme gravity would bend light and matter around the event horizon, concealing any clues. Even gravitational waves or other indirect signals might be subtle or masked by the chaotic environment of the black hole. The wormhole could exist for fleeting moments or persist for eons, a secret pathway threading through one of the most enigmatic regions of the cosmos. Stars, gas, and even entire solar systems falling into the black hole might never realize that such a tunnel exists, their fate influenced by a hidden architecture entirely invisible to ordinary observation. The implications are profound. A wormhole inside a black hole could theoretically provide a connection to distant parts of our galaxy or universe, bypassing light years of space. It might link to other black holes, forming a network of hidden passages, or connect to entirely separate universes, providing a route between realities that would otherwise be completely inaccessible. Matter entering such a tunnel could emerge in regions separated by unimaginable distances or under entirely different physical laws, making black holes not merely destructive objects but gateways, secret nodes in a hidden cosmic network. The journey through such a wormhole could be extraordinary. Gravitational tides inside the black hole could stretch and compress travelers in strange ways, yet the exotic matter could counteract the most destructive effects, allowing for safe passage. Light might refract and twist in impossible patterns, creating corridors of shifting stars, nebulae, and cosmic phenomena that fold over themselves. Time could dilate or contract in complex ways, producing a sensation of both instantaneity and eternity, a paradox of motion and stillness. Every moment might feel both fleeting and infinite, as the traveler navigates a tunnel threading the extreme curvature of space-time. Even the structure of the universe could be affected. If wormholes inside black holes exist, they could influence the formation of galaxies, the distribution of matter, and the propagation of energy. Dark matter, dark energy, and unexplained cosmic phenomena might be subtly guided by hidden tunnels within black holes, creating effects that are currently mysterious to astronomers and physicists. The galaxy itself could be more interconnected than it appears, with black holes serving not only as endpoints for matter but as hidden conduits linking distant regions of space and time. Philosophically, this possibility transforms our view of black holes, from destructive singularities to complex, dynamic gateways. The universe, vast and seemingly hostile, could harbor hidden pathways inside its most extreme objects, secret tunnels that thread through space-time, invisible yet profoundly influential. Matter, light, and information could traverse these hidden wormholes, shaping cosmic evolution in ways we cannot yet observe. The black holes would not be mere endings, but intersections, portals, and bridges in a universe far richer, stranger, and more interconnected than our senses allow us to perceive. Ultimately, could wormholes exist inside black holes? The answer is that it is theoretically possible, permitted by the mathematics of general relativity, enriched by the concept of exotic matter, and hidden from all current observation. If they exist, they are likely rare, fragile, and concealed, threading through the hearts of black holes in a network of invisible passages that connect distant points of space, distant epochs of time, and possibly even separate universes. The black holes, the ultimate cosmic enigmas, could harbor hidden corridors, secret tunnels threading through the most extreme regions of existence, waiting to reveal a universe far more interconnected and mysterious than we have ever imagined. Traveling through a wormhole is a journey that challenges every instinct, every expectation, and every understanding we have about space, time, and reality itself. To imagine it, we must first understand that a wormhole is not just a passage in space, but a bridge through the very fabric of space-time. A tunnel that could connect 2 points separated by thousands, millions, or even billions of light years, or perhaps even link entirely different universes. The experience would be unlike anything we can compare to on Earth, unlike any sensation produced by flight, free fall, or even the void of space, because it involves moving not merely through distance, but through the geometry of existence itself. At the moment of entry, the sensation might begin with the familiar, yet immediately warp into something entirely alien. Imagine approaching the mouth of a tunnel of light and darkness intertwined, the edges curving in impossible ways, bending your perception of up and down, near and far. Gravity may behave differently near the entrance. It might feel lighter, heavier, or stretch in directions that do not match your expectations. The air, if any surrounds you, might feel thicker, thinner, or absent entirely, though in space you would already be in a vacuum. The very passage through the wormhole could seem instantaneous, yet time might dilate, stretch, or compress in ways that defy ordinary experience. You could feel moments of extreme slowness, a stretching of consciousness, followed by bursts of incomprehensible speed, as though seconds extend into eternities and then collapse into blinks. Visually, the experience might be a cascade of impossible imagery. Light entering the wormhole could curve, reflect, and refract in ways our eyes and brains are not equipped to process. You might see stars, galaxies, and nebulae swirling around you, not in their normal positions, but twisted, folded, and layered over one another as the tunnel bends space-time. Colors might appear deeper, brighter, or entirely new, wavelengths of light shifted by the stretching and compression of space. The very concept of distance might dissolve. Points that seem far apart could appear adjacent, layers of the universe stacked in impossible configurations. Motion itself could feel circular, spiraling, or multi-directional, as the tunnel guides you along paths that are simultaneously straight and curved, near and far, familiar and utterly alien. The physical sensations could be extreme. Tidal forces inside a wormhole could stretch or compress your body along axes that do not correspond to familiar directions. You might feel elongated, flattened, twisted, or compressed, though a stable wormhole with sufficient exotic matter could mitigate destructive forces, preserving your integrity while still allowing the experience of bending space-time. Even subtle vibrations of the cosmic fabric could transmit through the wormhole, a faint hum or pulse that you feel in your bones and nerves, a resonance of the universe itself vibrating along the tunnel. Time, perception, and consciousness might warp in unexpected ways. Entering a wormhole could be like stepping into a place where past, present, and future overlap. You might sense events from one end of the tunnel unfolding while simultaneously perceiving the other end, as if consciousness itself is spread across space. Thoughts could feel faster or slower, moments could stretch or collapse, and memory could mingle with perception as the brain struggles to interpret an environment governed by rules that do not exist outside the tunnel. Sound, if perceivable at all, would be unlike anything on Earth. In a vacuum, ordinary sound waves do not travel, yet the exotic nature of the tunnel, the curvature of space-time, and the interaction with quantum fluctuations might create sensations analogous to sound. Pulses, vibrations, or harmonic resonances that seem to originate from all directions at once, sometimes overlapping or echoing across impossible distances. You could feel the symphony of the universe itself, a music that is spatial, temporal, and dimensional, vibrating along the tunnel walls in a rhythm tied to the very expansion and contraction of space-time. The psychological and emotional impact would be profound. Entering a wormhole would confront you with the strangeness of existence itself, the fragility of perception, and the malleability of reality. Fear, awe, and exhilaration might coexist in ways that seem contradictory. You might feel weightless yet anchored, accelerated yet suspended, tiny yet overwhelmingly vast, as if your consciousness is both alone and connected to the universe in ways that ordinary travel could never convey. The journey could produce a sense of unity with space-time, a profound awareness of the underlying geometry and flow of the cosmos. Exiting a wormhole would be equally disorienting. You might arrive in a distant part of your own galaxy, or perhaps in an entirely different universe with different physical laws. The light, the gravity, the chemistry of the surroundings could differ from what you expect. Stars might burn with unfamiliar colors. The sky might appear in layers or curves that defy Euclidean geometry, and the flow of time could be subtly shifted relative to your departure. Even if the journey seems instantaneous, you might emerge thousands, millions, or billions of years after entering, or in a region of space so alien that your senses struggle to comprehend it. The experience could be extended into near-infinite variety depending on the nature of the wormhole. A microscopic wormhole might produce fleeting sensations of curvature and stretch before collapsing. A massive interstellar wormhole could provide a smooth, extended traversal through impossible distances, a passage that feels like drifting through a tunnel of stars, light, and gravity. Each moment, a blend of motion and stillness, compression and expansion, illumination and shadow. A wormhole connecting universes could present entirely new physical realities, where matter behaves differently, light is altered, and even consciousness itself feels shifted by the unfamiliar rules governing that universe. Ultimately, traveling through a wormhole is an experience that cannot be fully captured by analogy, for it is not merely motion through space, but movement through the geometry of existence. It is a journey where distance, time, and perception dissolve, where the mind struggles to comprehend the vast and subtle distortions of reality, where the universe reveals its hidden structure in flashes of sensation, light, gravity, and resonance. It is a journey of awe, danger, wonder, and discovery, a traversal not only through cosmic space but through the very laws that define what is possible. Could the Milky Way itself be linked by hidden wormholes is a question that expands across imagination, theory, and the vast scales of our galaxy in ways that are almost impossible to fully visualize. Yet it is rooted in some of the most profound ideas in physics and cosmology. Wormholes are theoretical passages through space-time, solutions to Einstein's general relativity equations, tunnels that could, in principle, connect distant points across the galaxy or even the universe, allowing instant travel between locations that would otherwise be separated by tens of thousands of light-years or more. While no wormhole has ever been observed, the equations allow their existence, and the possibility that such structures could thread our galaxy is both mind-boggling and scientifically tantalizing. Imagine the Milky Way, a vast spiral stretching 100,000 light-years across, containing hundreds of billions of stars, clusters of gas and dust, black holes, pulsars, and planets. The distances are so immense that even light, moving at the ultimate speed limit, takes tens of thousands of years to cross from one end to the other. If hidden wormholes exist within this enormous structure, they could serve as shortcuts through the cosmic fabric, linking the galactic core to the outer spiral arms, connecting remote star clusters, or even bridging regions of space where the ordinary flow of time and distance would normally make travel impossible. These tunnels could be stable or fleeting, tiny or massive, detectable or entirely invisible depending on their nature and the exotic matter that might sustain them. Theoretical physics suggests that wormholes require extreme conditions to exist. They are thought to need exotic matter, matter with negative energy density, to remain open without collapsing. The Milky Way contains some of the most extreme environments imaginable, from the supermassive black hole at its center to neutron stars spinning hundreds of times per second, from magnetic fields that extend across hundreds of light years to dense molecular clouds full of dust and gas. Could some of these environments provide the conditions necessary to create or sustain a wormhole? Perhaps the collision of massive objects, the twisting of space-time around black holes, or the peculiar dynamics of dark matter filaments could give rise to hidden tunnels, brief bridges through space that blink in and out of existence, carrying matter or information in ways we have yet to detect. If wormholes thread the Milky Way, their effects might already be observable in subtle ways. Cosmic rays, high-energy particles, might arrive from directions that seem impossible. Stars might move in ways that defy the gravitational influences we can account for. Gravitational lensing could reveal distortions that cannot be traced to visible matter alone. Perhaps some of the unexplained bursts of energy or anomalies in stellar motion hint at the existence of these hidden pathways. The galaxy could be far more interconnected than our telescopes and instruments currently suggest, with invisible threads linking regions of space that would otherwise seem completely independent. The implications for travel, communication, and the spread of life are staggering. If even a few stable wormholes exist within the Milky Way, they could theoretically allow instant travel across the galaxy, bypassing the limits of light speed. A signal could traverse tens of thousands of light years in moments. A starship could move from one arm of the galaxy to another in a blink of an eye, and regions separated by vast distances could interact in ways that would otherwise be impossible. The Milky Way would no longer be a slow-moving spiral of stars and gas, but a dynamic, interconnected network where distance is not absolute, where isolation is an illusion, and where the hidden architecture of space-time reshapes our understanding of the galaxy itself. The hidden nature of wormholes is crucial. Even if they exist, detecting them is extraordinarily difficult. Their entrances could be minuscule, hidden within black holes, near neutron stars, or cloaked by the immense darkness of interstellar space. Exotic matter might be required to stabilize them, and even then they could fluctuate, collapse, or be unstable for long durations. Traveling through a wormhole, if it were possible, could be dangerous, with tidal forces stretching matter, radiation bombardments from outside, or even collapse during transit. Yet the possibility remains, tantalizing and theoretically sound, that wormholes could form a hidden lattice threading the Milky Way, invisible yet integral to the structure of the galaxy. Consider the philosophical implications. The Milky Way as a simple spiral of stars gives way to a vision of a galaxy as a living, dynamic network, where apparent distances are not absolute, where the vastness of space is interwoven with invisible corridors, and where stars, clusters, and planets may be connected in ways that transcend light years. The galaxy becomes more than a collection of matter. It becomes a system of potential connections, a web of possibility, a cosmic organism threaded with shortcuts through space-time that could link the fate of distant regions. These wormholes, hidden and mysterious, could influence the motion of matter, the flow of energy, and the evolution of structures in ways that are subtle yet profound, shaping the Milky Way in a dimension we have yet to observe. Even the light reaching Earth may carry hints of this hidden network. Photons traveling across the galaxy could pass near or through a wormhole, arriving earlier or later than expected, their paths subtly deflected, their energies altered. Gravitational lensing, already used to detect massive objects like dark matter, could in principle reveal these hidden tunnels if we know what to look for. Subtle distortions in the motion of stars or gas clouds could hint at the presence of space-time shortcuts, a hidden dimension of connectivity underlying the apparent vast emptiness between stars. Furthermore, wormholes could connect regions of the Milky Way to areas far beyond, even other galaxies. if they exist on larger scales. This would transform the galaxy from a seemingly isolated structure into a node within a much larger cosmic network. The Milky Way might be one of countless galaxies interconnected by hidden pathways, the motions of stars and light influenced not only by local gravity but by distant regions linked through space-time tunnels. The galaxy, in this vision, is both local and global, self-contained and interconnected, finite in some ways yet infinite in its potential connections. Ultimately, could the Milky Way itself be linked by hidden wormholes remains one of the most tantalizing possibilities in modern astrophysics. The theory allows it. The galaxy contains the conditions that might support it, and subtle clues may already exist in the behavior of light, matter, and energy. Yet these structures, if they exist, are elusive, hidden, and almost impossible to detect with current technology. They remind us that the galaxy we see with telescopes is only part of the story, that the universe may contain hidden dimensions, secret highways, and connections that are invisible yet fundamental. The Milky Way may not be merely a vast spiral of stars and gas, but a dynamic, interconnected web threaded with hidden wormholes, linking distant corners of the galaxy, shaping motion, light, and energy in ways that we have only begun to imagine, and inviting us to expand our understanding of space, time, and the hidden architecture of the cosmos itself. If a wormhole could appear suddenly in deep space, it would be one of the most breathtaking, terrifying, and mysterious events the universe could ever produce. Imagine a place far beyond the reach of stars, where the darkness is absolute, where dust drifts like forgotten echoes, and the only light comes from distant galaxies, each one a faint shimmer across the cosmic sea. Then, out of that silence, space itself begins to ripple, like the surface of still water disturbed by something unseen. There is no explosion, no flash, no sound, only a distortion, a slow bending of reality that deepens until a shape begins to form. That shape could be a wormhole, a sudden doorway carved through the invisible geometry of space-time. It would not look like a hole in the way we imagine holes on Earth. It would be more like a shimmering sphere, an opening surrounded by light that bends backward into itself. Stars behind it might appear twisted, stretched, or multiplied, their light curving in impossible ways. The space around it would tremble with energy, not heat or motion as we know it, but the deep, silent hum of space-time rearranging itself. If you were close enough, you would not see the wormhole open. You would feel it, as though gravity had changed its mind about which direction was down. Physicists have long wondered whether wormholes could form naturally, just as stars and galaxies do. In theory, the equations of general relativity allow for them, but the conditions required are so extreme that they may only exist for brief moments. Some think that in the earliest moments of the universe, when everything was dense and chaotic, tiny wormholes could have appeared everywhere, connecting random points across the young cosmos. Most of them would have collapsed almost instantly, torn apart by the immense energy of expansion. But a few perhaps could have survived, hidden in the quiet reaches of deep space, waiting silently ever since. If one were to appear now, it might come from the violent death of a massive star, or from the merging of two black holes. When such titanic events shake the fabric of space-time, they release waves of energy that can echo across billions of light years. Sometimes, those ripples could twist space-time enough to momentarily form a tunnel, a shortcut from one region of the universe to another. It might last a fraction of a second, or it might stabilize if exotic forms of matter, with negative energy, exist to hold it open. Now imagine that happening in a dark corner of the galaxy. There are no planets, no suns, only drifting gas and dust. Then, suddenly, space-time folds, and a wormhole blooms into existence. From a distance, it could look like a glowing sphere, surrounded by arcs of distorted starlight, with faint vibrations of energy radiating outward. To any nearby object, a lonely asteroid, a wandering comet, the gravitational field would shift without warning. The objects might begin to drift toward the new structure, caught in its pull. Light entering the mouth would vanish instantly, swallowed without a trace. What would it be like to stand near one of these sudden gateways? If you were an observer in a ship, watching from a safe distance, you might see the edges of your reality begin to warp. Space would seem to curve, and the background stars would ripple like reflections in disturbed water. The sensors on your ship would start to pick up strange readings, distortions in time, bursts of gravity waves, and maybe even flashes of radiation. The wormhole's mouth might flicker between shapes, sometimes a sphere, sometimes a ring, as it struggled to stabilize. If it remained open, it could lead anywhere or any time. The far side might open near another galaxy, or perhaps in the deep past, or even in the distant future. The wormhole does not follow human logic. It is a connection defined by geometry, not by reason. From our perspective, it would appear as though the universe had folded in on itself, creating a bridge between two faraway points with no warning and no clear cause. There's also a haunting question. What if a wormhole didn't appear suddenly, but was always there, invisible until something passed near enough to awaken it? Space could be full of hidden tunnels, folded paths through dimensions we cannot yet detect. Some might be tiny, smaller than atoms, flickering in and out of existence. Others could be vast, stretching light years across, waiting silently in the dark. If one of those suddenly opened near a star system, it could change everything about the local balance of gravity. Planets might shift slightly, orbits might tilt, and the faint background of cosmic radiation might ripple like a whisper from across the universe. If light fell into that wormhole, what would happen next? It would not move in a straight line anymore. It would spiral inward, following the curve of warped space-time until it reached the throat, then vanish into another place. Perhaps that light would emerge elsewhere, faint and distorted, arriving billions of years after it began its journey. Or maybe it would never emerge at all, trapped forever in the endless curvature of the wormhole's inner geometry. To an observer billions of kilometers away, the sudden birth of a wormhole would look like the universe blinking. One moment, everything is calm. The next, the stars behind a region of space shift slightly, their light stretched and bent. Then the distortion fades, and the stars return to normal except, perhaps, for one, which no longer shines as it once did, because its light has been swallowed and carried elsewhere. The very idea of a wormhole suddenly appearing reminds us that space is not empty. It is flexible, alive in a sense, shaped by mass and motion and time. Even in the darkest reaches where nothing seems to move, the fabric of space-time is never still. It trembles with invisible energy, with quantum fluctuations that might, under the right conditions, tear a hole through the universe and open a tunnel to somewhere else. And if one truly appeared, if astronomers detected the sudden bending of light and gravity that marked its birth, humanity would face the ultimate question: would we dare to enter? Would we send a probe, or wait, or simply watch in awe as the universe revealed one of its deepest secrets? Because a wormhole is not just a hole through space. It is a question made real. A question about connection, distance, and the meaning of here and there. So yes, a wormhole could appear suddenly in deep space, though it would not be sudden to the universe itself. It would be the natural unfolding of geometry, the inevitable dance of gravity and energy, written in the silent language of space-time. To us, it would seem miraculous, impossible, breathtaking. To the cosmos, it would be just another curve, another whisper in the endless motion of existence. a reminder that even in the deepest silence, the universe is still creating, still folding, still dreaming of the places that lie beyond our reach. If a wormhole truly exists, then it is not just a bridge through space, but also through time itself. The idea that time could flow differently on each side is one of the most fascinating consequences of Einstein's theories. Time is not an independent ticking clock that exists outside the universe. It bends and stretches with gravity, with speed, with energy, and with the shape of space-time itself. A wormhole would be like a fold in that fabric, pulling two distant places together, but at the same time bending the rhythm of seconds, minutes, and hours on either side. Imagine you are standing near the mouth of a wormhole. The space around you feels normal at first, calm and still. But the closer you step toward the edge, the stronger the pull becomes. The light bends slightly, as if the air itself is trembling. If you could look through, you might see a distant part of the universe, a different galaxy, or even another era in time. To you, only a moment might have passed, but for someone watching from the outside, years or centuries might be slipping away. Time could crawl near your side of the wormhole while it races wildly on the other. This difference happens because of how gravity affects time. Near intense gravity, time slows down. The stronger the gravitational field, the slower the seconds pass. Near a black hole, this effect is extreme, and since wormholes are thought to form from the same strange geometry that shapes black holes, it is likely that one end of a wormhole could sit in stronger gravity than the other. That means a person waiting on one side could experience time moving much faster or slower than the person who entered the opposite mouth. You could step into the wormhole, stay for what feels like a few minutes, and return to find that centuries have passed outside. Now imagine what that means for communication, for travel, for memory itself. If a civilization discovered how to control wormholes, they would also control the flow of time. They could send messages to their own past, or travel to the far future by simply crossing through. But there would be a price. The synchronization of time between the two ends would constantly shift, creating strange effects that would make it nearly impossible to line up events perfectly. One side might always be older, the other always younger, a cosmic imbalance that could never be fully equalized. Even light would experience this difference. If you shined a beam from one end, its frequency might stretch or compress as it emerged on the other side. To the observer, it could appear redder or bluer, depending on how time was flowing. This would mean that even something as constant as light would not remain the same across a wormhole. Every particle, every photon, every vibration of space itself would feel the difference in time. Some physicists think that if a wormhole connects two points in space that exist at different times, it could actually become a kind of natural time machine. Travel one way, and you go into the future. Travel the other way, and you arrive in the past. This would make the wormhole not only a tunnel through the universe, but through history itself. Yet, such an object might also be unstable. The flow of energy between the two mouths could rip it apart, or quantum effects could collapse it before anything could pass through. Still, the thought lingers. If time does flow slower on one side of a wormhole, then reality itself would have a rhythm, a pulse that changes from one place to another. You could stand at the entrance and watch the other end glowing faintly, aware that what you see is not happening now, but in another slice of time. Maybe that light is from a past long gone. Maybe it is from a future that has not yet happened. To look through a wormhole would be to look across the seams of existence. It makes you wonder how differently life might unfold if time did not move the same everywhere. What would it mean to live in a place where one heartbeat could last 1,000 years, while another side of the same connection sees whole civilizations rise and fall in a moment? Would those two sides ever understand each other? Would the flow of memory and meaning be distorted beyond recognition? The deeper truth is that time and space are not separate things at all. They are part of one vast continuum, woven together so tightly that bending one inevitably distorts the other. A wormhole, if it exists, is not just a passage through distance, but through the structure of reality itself. It shows us that movement and existence are never as simple as they seem. Every second you experience, every moment you remember, is already part of that vast web of connections stretching across the universe. So yes, time could flow slower on one side of a wormhole than the other, not because the clocks themselves are broken, but because the universe is not built on straight lines or uniform rhythms. It is built on curves and gravity and energy and mystery. And somewhere out there, perhaps hidden inside the folds of space-time, there may already be tunnels where time itself changes speed, whispering softly as the universe keeps expanding, always inviting us to wonder what lies on the other side. Could we send a message through a wormhole before it collapses? Is a question that stretches our imagination and our understanding of physics, inviting us to consider not only the incredible mechanics of space-time, but also the delicate timing, precision, and extraordinary circumstances required to communicate through a structure that may exist for only fleeting moments in the cosmic landscape. Wormholes, if they exist, are tunnels threading the fabric of space-time, potentially connecting distant points in the universe, or even entirely different regions of reality. But their stability is precarious, dependent on exotic matter with negative energy density to prevent them from collapsing under the immense gravitational forces that would otherwise pinch them shut almost instantly. To attempt to send a message through such a wormhole requires not only knowing of its existence, but understanding its timing, geometry, and the way energy and information propagate through its interior. Imagine a wormhole forming in deep space, its entrance shimmering faintly as light bends around the curved space-time. Exotic matter stabilizes it temporarily, resisting the pull of gravity and allowing a tunnel to remain open. For any signal, be it light, radio waves, or even a stream of particles to traverse this tunnel, it must enter the wormhole while the structure is still intact. Time itself may behave unusually inside, stretching, compressing, or twisting in response to the curvature and energy distribution. The signal would be carried along a path that is far shorter than the equivalent distance through ordinary space, arriving at a distant region potentially millions or billions of light-years away almost instantaneously from the sender's perspective, though the timing may appear complex from the outside. The challenge of sending such a message is enormous. First, one must locate a wormhole, an invisible tunnel that does not emit ordinary light and may only be inferred through gravitational lensing or subtle distortions in surrounding matter. Second, one must synchronize the message with the stability of the wormhole. Wormholes may form, fluctuate, or collapse on timescales ranging from fractions of a second to millions of years, and misjudging the timing could result in the signal being trapped, scattered, or destroyed. The act of sending a message might itself influence the wormhole, as energy and matter entering the tunnel could perturb the delicate balance maintained by exotic matter, shortening the lifespan of the tunnel or altering its exit point in ways that complicate delivery. Consider the journey of a message entering a wormhole. As it traverses the interior, space-time curvature may stretch and compress the wavelength of light or electromagnetic radiation, bending it around corners of the tunnel that are invisible in ordinary perception. Time dilation effects could make the journey feel instantaneous to the signal itself, while outside observers might perceive distortions or anomalies in timing, frequency, or intensity. The message could experience multiple possible pathways within the wormhole, with some portions arriving at different points or times, reflecting the complex geometry and the evolution of the wormhole itself over the course of billions of years. Even the act of communication is profoundly affected by quantum phenomena. Information traveling through a wormhole could interact with the quantum fluctuations of the exotic matter, stabilizing the tunnel, producing subtle changes in the signal. Entanglement, superposition, or other quantum effects might allow information to propagate in ways that appear non-local, connecting distant points in space instantaneously, while the precise outcome depends on the fragile state of the wormhole at the moment of transmission. Noise, interference, or decoherence could disrupt the message, requiring extraordinary precision in encoding, timing, and energy distribution to ensure successful delivery. Visualizing this, one could imagine a beam of light or a stream of encoded particles entering a shimmering distortion in space. The surroundings ripple with gravitational distortions, stars and galaxies bending and stretching as the wormhole subtly reacts to the passage of the signal. Inside the tunnel, the message travels along a corridor where space and time are twisted, distances shortened, and causality behaving in ways unfamiliar to ordinary physics. The light might curve, twist, or loop, tracing a path through dimensions that seem to fold upon themselves, carrying information through a landscape where ordinary intuition no longer applies. The collapse of the wormhole adds another layer of complexity. If the tunnel begins to pinch shut, the signal must exit before the interior shrinks beyond traversable dimensions. The timing is critical. Enter too late, and the message is trapped or destroyed. Too early, and the exit may not yet be aligned with the intended destination. The process may require anticipating the evolution of the wormhole, calculating the gravitational and quantum forces at play, and launching the message with precision measured in fractions of cosmic seconds. The physics of collapse is dramatic, as tidal forces could stretch the signal, alter its frequency, or even partially disintegrate it, leaving only fragments to emerge, if anything at all. Beyond the technical challenges, the philosophical implications are profound. Sending a message through a wormhole is not simply bridging a distance, but reaching across the fundamental structure of reality, communicating through a corridor that defies ordinary constraints of space and time. The message could emerge in a galaxy far across the universe, in a different epoch of history, or even in a parallel branch of possibility, transforming our understanding of communication, causality, and connectivity. A single message sent through such a tunnel carries with it not only information but a record of the dynamic, evolving cosmos it traversed, encoding both the path taken and the fleeting state of the wormhole itself. Over billions of years, the possibility of sending messages through wormholes could shape cosmic interactions in subtle ways. Civilizations might exploit temporary tunnels to exchange information across vast distances. Stars might be observed in unusual configurations because light or radiation took shortcuts through hidden passages. And energy flows could be subtly redirected through these ephemeral corridors, influencing the formation of galaxies, clusters, and cosmic structures. The universe itself might contain a hidden network of transient connections, each tunnel opening briefly to allow passage of information, matter, or energy before vanishing, leaving no trace except the consequences of what was transmitted. Ultimately, the act of sending a message through a wormhole before it collapses is a profound testament to the interplay of physics, timing, and cosmic opportunity. It requires understanding not just space but the hidden architecture of the universe, anticipating the delicate balance of exotic matter, gravitational forces, and quantum fluctuations, and threading information through corridors that may exist only for moments measured on cosmic scales. The message, if successful, emerges as a bridge across space and time, a proof of connection through a hidden dimension of reality, a whisper carried along a path shaped by the extraordinary and the unseen. Wormholes, in this view, are not merely theoretical curiosities but potential channels for communication across the cosmos, fleeting yet powerful, challenging our understanding of the universe and revealing that information, like matter and energy, may traverse corridors that defy ordinary comprehension. Could wormholes lead not to places, but to possibilities, is a question that stretches both imagination and physics, inviting us to consider the universe not merely as a collection of stars, galaxies, and empty space, but as a web of potential realities, where hidden tunnels through space-time might connect not just locations, but different outcomes, alternate histories, and entire branches of what could be, creating a cosmic landscape of infinite possibility. In conventional understanding, wormholes are envisioned as tunnels connecting distant points in space, shortcuts through the curvature of the universe, allowing matter, light, or information to traverse immense distances in ways that ordinary travel cannot. But what if these tunnels are more than just spatial shortcuts? What if, instead of or in addition to linking points in space, they link different pathways of events, alternate sequences of reality, or divergent versions of the universe itself, revealing that the fabric of existence is threaded not only with space and time, but with potentiality itself? Imagine a tunnel appearing in a region of deep space, its entrance shimmering faintly as starlight bends around the invisible curvature. A photon entering this tunnel might emerge not in a distant galaxy, but in a version of that galaxy shaped by different events, a universe where stars form differently, where planets follow altered orbits, or where history itself unfolded along an entirely different trajectory. Every particle passing through could carry with it the influence of choice, of chance, of the branching of reality, creating a pathway that is less about location and more about the manifestation of alternative possibilities. The wormhole becomes a corridor through the multiverse, a bridge linking what exists to what could exist, a pathway for potential rather than mere presence. The physics of such a phenomenon would be extraordinary. In general relativity, wormholes are solutions to the equations that describe space-time curvature, requiring exotic matter to stabilize them against collapse. If the universe is a quantum landscape, where each possible event corresponds to a branching of reality, then a wormhole might serve as a conduit between branches, allowing connections between histories, probabilities, and outcomes. Matter passing through such a wormhole would not merely move through space but traverse a network of possibilities, interacting with alternate realities in ways that are subtle, probabilistic, and complex. Light, energy, and particles could carry the imprints of multiple potential paths, emerging not just in a different location, but in a slightly different version of the universe, where circumstances are altered yet recognizable. Visualize this in a sensory way. A traveler approaching such a wormhole might see faint flickers of alternative skies, glimpses of stars burning in patterns that do not exist in their current reality, constellations that are familiar yet rearranged, galaxies glowing in colors and forms that suggest histories that might have been. Entering the tunnel, the experience could feel like passing through a kaleidoscope of potentialities, where each moment contains echoes of what could have been and might yet become. Light might split into shimmering strands, each representing a different sequence of events, creating a corridor alive with the echoes of branching realities, vibrating with the energy of possibility itself. The temporal implications are equally profound. If wormholes can connect possibilities, then time itself may be experienced differently within them. A single instant could unfold into multiple pathways simultaneously, with cause and effect becoming interwoven threads rather than a simple sequence. Events that appear inevitable in one universe may coexist alongside alternatives in parallel branches, and the wormhole could act as a mediator, linking outcomes across temporal and probabilistic dimensions. The traveler might sense moments repeating, diverging, folding back on themselves, each step through the tunnel revealing the infinite tapestry of what could occur, allowing a perception of time as a fluid, branching, and multidimensional phenomenon. Wormholes leading to possibilities could also offer explanations for certain cosmic mysteries. Sudden appearances of matter or energy, unexpected alignments of stars, anomalies in galactic motion, or unusual bursts of light might reflect interactions with alternative realities accessed through hidden tunnels. A star might vanish from one branch of reality and reappear in another. A planet might flicker between slightly different histories, and the subtle distortions in space-time could be a record of these interactions. Dark matter and dark energy, which already elude direct detection, could play a role in stabilizing or guiding these possibility tunnels, influencing which branches are connected and shaping the flow of outcomes in ways that are invisible yet consequential. Philosophically, this perspective transforms our understanding of existence. Reality is no longer a single, fixed path, but a vast web of potentialities, each branch as real as the one we perceive, each choice, event, and interaction forming part of a multidimensional tapestry. Wormholes, in this context, are not just bridges through space or time, but conduits of potential, gateways through which matter, energy, or consciousness might explore what might have been, what might yet become, and what exists in dimensions beyond ordinary perception. The universe becomes a living, evolving network of possibilities, a dynamic interplay of actuality and potential, with hidden tunnels threading through the structure of reality itself. Imagine a cosmic journey through such a wormhole. As a traveler moves through the tunnel, galaxies shimmer with alternative formations, stars pulse with different life cycles, and entire regions of space seem to flicker between multiple states. Light carries not only information about location, but the energy of probability, revealing how events might have unfolded differently. The very sensation of movement could feel paradoxical, as if stepping through the corridor allows one to exist simultaneously in multiple outcomes, glimpsing realities that are adjacent, overlapping, and interconnected in ways that defy ordinary understanding. Even on a human scale, the idea is profound. The choices we make, the paths we take, and the actions we perform could all be mirrored or branched across the network of possibilities. A wormhole connecting such branches would not only be a cosmic feature, but a reminder that existence itself is richer and more complex than our limited perception allows. The universe might contain countless hidden tunnels linking outcomes, some influencing stars and galaxies, others subtly shaping events on planets, and some perhaps guiding the very evolution of consciousness in ways imperceptible yet real. Over billions of years, these possibility wormholes could evolve, their geometry shifting, their entrances appearing and disappearing, their connections to alternative realities forming, dissolving, and reforming. The universe becomes a dynamic, living fabric where matter, energy, and potential flow through hidden corridors, shaping outcomes across space, time, and probability. What we perceive as chance, coincidence, or anomaly could be the visible effect of these tunnels guiding possibilities, the hidden architecture of what could exist intertwined with what does exist. Ultimately, the idea that wormholes could lead to possibilities invites us to imagine the universe as an infinite, interconnected lattice of reality, where space and time are threads but potential itself is a river flowing through hidden tunnels. Stars, galaxies, particles, and even consciousness might traverse these passages, exploring alternate paths, linking realities, and shaping the cosmic tapestry. The universe is not merely a map of locations or a sequence of moments, but a web of potentialities, a living, evolving structure threaded with wormholes that connect what is to what could be, revealing that possibility itself might be as real, intricate, and vital as the matter and energy we can observe. Could wormholes evolve over billions of years is a question that immediately invites us to think of these mysterious structures not as static, fixed anomalies, but as dynamic, living features of the cosmos, subject to the same processes of change, decay, and transformation that govern stars, galaxies, and the universe itself, stretching imagination and physics to the limits of understanding. Wormholes, if they exist, are hypothetical tunnels through the fabric of space-time, connections between distant points in space, time, or even between entire universes, held open by exotic matter with negative energy density that counteracts the immense gravitational forces attempting to collapse them. Yet the universe is not a static place. Over billions of years, cosmic structures evolve, energy flows, matter moves, and space-time itself stretches and bends. And wormholes, embedded in this ever-changing cosmic web, would be subject to similar transformations. Imagine a wormhole forming in the early universe, perhaps in the first few million years after the Big Bang, when energy densities were extreme, matter was in its earliest configurations, and space-time itself was inflating rapidly. Its entrance might appear as a subtle distortion in space, a minuscule curvature that only affects passing particles or light, invisible to ordinary observation. Over the eons, as galaxies form, stars ignite and die, and cosmic expansion stretches the very fabric of space-time, the wormhole itself could grow, shrink, shift, or even split, its geometry responding to surrounding mass, energy flows, and gravitational tides. It might remain stable for billions of years, or it might slowly collapse, opening briefly and closing, existing in cycles that defy ordinary human perception. The evolution of a wormhole could involve complex interactions with dark matter, dark energy, and ordinary matter. Streams of gas or radiation passing near its entrance could distort its shape, creating ripples in the tunnel. Gravitational waves generated by merging black holes or massive supernovae could propagate through the wormhole, subtly altering its curvature, widening the passage, or twisting its spatial and temporal geometry. Exotic matter maintaining the wormhole might fluctuate over time, slowly decaying or strengthening, producing periods of stability punctuated by instability, creating openings and closings that last centuries, millennia, or millions of years from an external observer's point of view. Visualizing such evolution is extraordinary. Picture a wormhole as a tunnel threading space, its entrance surrounded by distorted starlight, a shimmer of bending photons that subtly hints at the hidden corridor. Over millions of years, nearby stars move along their orbits, galaxies rotate, and cosmic flows of matter pass by, each interaction subtly tugging at the wormhole, stretching it in one direction, compressing it in another. Light passing through could twist and loop, creating ghostly reflections of distant galaxies and nebulae. Exotic matter within the tunnel might respond to the changing gravitational landscape, its density fluctuating like a cosmic heartbeat, subtly altering the interior passage so that a traveler moving through it over billions of years would perceive corridors widening and contracting, loops forming and dissolving, and a dynamic architecture of space itself. Time within an evolving wormhole could behave unpredictably. If one end of the tunnel is embedded in a region of strong gravitational curvature, while the other resides in a relatively flat or expanding region of space, time dilation could vary along the length of the tunnel. A journey that appears instantaneous at one moment might stretch into eons at another. As the wormhole evolves, the experience of passage could change, making it feel sometimes like a brief blink, sometimes like a journey through eternity, with moments folding, stretching, and looping in complex patterns that challenge conventional perception. The evolution of wormholes over cosmic time could also affect their connections. A tunnel linking two regions of space might gradually drift, its exits moving as galaxies orbit and cosmic expansion unfolds. What was once a shortcut between two stars in a galaxy could, over billions of years, link entirely different regions, perhaps connecting galaxies billions of light years apart, or even emerging in regions of space yet to form in the distant future. The cosmic landscape itself evolves, and wormholes embedded within it evolve too, their topology responding to forces, energy, and matter in ways that are subtle, slow, yet profound. Furthermore, wormhole evolution might explain some mysteries in astronomy. Sudden appearances or disappearances of matter, anomalous motions of stars, or subtle distortions in gravitational lensing could reflect the shifting geometry of a wormhole over billions of years. A wormhole that was stable in one epoch might close, hiding objects that once passed through, while in another era it might open, allowing new material or energy to traverse from one corner of the universe to another. The slow evolution of these tunnels could produce patterns that are almost imperceptible, yet over cosmic timescales, they could influence the structure of galaxies, clusters, and even the large-scale web of the universe. From a sensory perspective, traveling through an evolving wormhole would be extraordinary. Light might swirl in shifting patterns, reflecting the tunnel's changing shape. Stars and galaxies outside could bend and twist as the wormhole responds to gravitational tides. Inside, the passage could stretch and contract, loops forming and dissolving, the geometry twisting in ways that defy ordinary perception. Time might accelerate or decelerate along different segments of the tunnel, producing a sense of both instantaneity and eternity simultaneously. A traveler would feel the universe itself alive, its rhythms unfolding, pulsing, and evolving as the wormhole responds to the cosmic ballet outside. Even more profound, wormholes evolving over billions of years could connect epochs as well as spaces. A tunnel formed in the early universe might allow matter or information to travel into the far future, carrying the imprint of its origin across eons. Cosmic events, the birth and death of stars, the formation of galaxies, and the flow of dark energy might all subtly influence the wormhole, imprinting a record of cosmic evolution within its structure. Each journey through such a wormhole would then be a journey through both space and time, experiencing the accumulated history of the universe in a single passage. Ultimately, the evolution of wormholes over billions of years transforms them from static curiosities into dynamic, living features of the cosmos. They are not merely bridges through space, but evolving corridors shaped by gravity, energy, and matter, responding to the motions of galaxies, the flow of dark matter, and the expansion of the universe itself. Over eons, their entrances and exits drift, their geometry twists, their interiors stretch and fold, and their temporal properties shift, creating hidden networks that influence matter, energy, and the unfolding of cosmic history. Wormholes, in this view, are not just theoretical possibilities, but dynamic participants in the life of the universe, silent architects shaping the flow of matter, light, and time across billions of years. Could the Big Bang have been the opening of a wormhole is a question that stretches the imagination across the very edges of physics, cosmology, and speculative thought, merging the birth of our universe with one of the most exotic possibilities in space-time theory, and inviting us to consider the origins of everything as not merely an explosion of matter and energy, but as a passage, a bridge, a doorway to realities beyond comprehension. The Big Bang is understood as the beginning of the observable universe, a moment when space, time, matter, and energy expanded from a singularity into the cosmos we inhabit today. But what if this singularity was not an isolated event, not the absolute beginning, but the mouth of a wormhole, a tunnel that connects our universe to some pre-existing space, another universe, or a deeper layer of reality beyond our current perception? Consider what it would mean for the Big Bang to be a wormhole opening. A wormhole, according to Einstein and Rosen, is a solution to general relativity equations that describes a tunnel through the fabric of space-time. Normally, we imagine wormholes connecting distant points within our own universe, acting as shortcuts across unimaginable distances. But there is nothing in the mathematics of space-time that prevents a tunnel from connecting not just regions of space, but entire realities, entire universes. If the Big Bang were such an opening, then our universe did not emerge from nothing. It emerged from a connection, a passage, a corridor linking the cosmos we know to something that existed before or alongside it, something external, something hidden from our perception. The physics of this idea is staggering. The singularity at the heart of the Big Bang is characterized by infinite density and temperature, a breakdown of classical physics where space and time themselves are undefined. A wormhole, if threaded through this singularity, could have provided a pathway for energy, matter, or information to emerge, to expand, to blossom into the cosmos we observe. The extreme curvature of space-time, the immense energies, and the rapid inflation of the early universe could all be interpreted as features of a tunnel that stretches and unfurls as matter pours through, a corridor that expands into the four-dimensional fabric of our reality. In this sense, the universe's rapid expansion in the first moments after the Big Bang could be analogous to the stretching of a wormhole, the tunnel widening to accommodate the flow of space and energy. Imagine the opening of this cosmic wormhole as both violent and subtle. From the inside, matter and energy would be propelled outward, creating the expansion we perceive as the Big Bang. Light, particles, and fields would emerge in an intricate ballet, interacting, colliding, and forming the first atoms, stars, and galaxies. From the outside, if such a perspective were even possible, the birth of our universe might appear as a conduit, a transfer of energy from one realm into another, a tunnel feeding the cosmos with the raw material for stars, planets, and life. Space itself would be newly formed, but intrinsically connected through the tunnel to whatever lies beyond, a bridge between reality as we know it and an origin we cannot observe directly. The implications for time are profound. If the Big Bang were the opening of a wormhole, then the concept of before the Big Bang might have meaning. Instead of being the absolute beginning, it could be a point along a continuum, a threshold connecting our universe to a parent universe, or a higher dimensional bulk in which multiple universes exist. Time inside the wormhole could behave differently, dilating, contracting, or looping in ways that allow causality to remain consistent across realities, while still permitting the emergence of an entire cosmos from what appears to us as a singular event. The arrow of time in our universe, the unfolding of cause and effect, the evolution of entropy, the birth and death of stars could be intimately linked to the geometry of the tunnel that created it. The flow of matter and energy through a passage that transcends our ordinary understanding of past, present, and future. The cosmic microwave background radiation, the faint afterglow of the Big Bang, could also be interpreted in this context as the lingering imprint of matter and energy passing through the wormhole, a subtle fingerprint of the tunnel's opening. Tiny fluctuations in temperature and density, which seeded the formation of galaxies and large-scale structure, could reflect the irregularities and geometry of the wormhole itself. Dark matter and dark energy, which dominate the mass-energy content of our universe yet remain mysterious, might be remnants or influences of the tunnel's structure, threads connecting our cosmos to whatever lies beyond, the ghostly architecture of a higher dimensional corridor. Philosophically, the idea transforms our understanding of existence. The Big Bang is not merely a beginning, it is a passage. Our universe might be only one of countless others, each born from its own cosmic wormhole, each a separate bubble in an infinite multiverse, each connected through a hidden web of tunnels that thread reality itself. The matter and energy in our universe might have origins that stretch beyond space and time as we know them, hints of a greater reality, a larger cosmos in which birth, death, and existence are threads woven together by the geometry of space-time itself. Traveling through such a wormhole, if one could, might allow glimpses of a universe before the Big Bang, a pre-existing reality that fed ours. One might see structures, energies, or dimensions entirely alien to our comprehension, a landscape where physics operates differently, yet from which our own cosmos emerged. The journey could feel both instantaneous and eternal, a paradox reflecting the dual nature of wormhole travel itself, where time, space, and perception are warped into a tapestry that stretches beyond imagination. Even the expansion of our universe, which continues today, could be related to the ongoing influence of the original tunnel. Inflation, the rapid growth in the earliest moments, might be analogous to the stretching of the wormhole's passage as energy poured through. The cosmic web of galaxies, clusters, and filaments might trace patterns determined by the geometry of that initial tunnel, suggesting a hidden order that is only subtly perceptible, yet imprinted in the large-scale structure of space-time itself. Ultimately, the question of whether the Big Bang could have been the opening of a wormhole invites us to see our universe not as a solitary explosion from nothing, but as part of a larger, interconnected reality. The tunnel that birthed our cosmos could link to other universes, other dimensions, or realms beyond human observation, forming a hidden web in which creation itself is a passage, a journey, a bridge between the conceivable and the unimaginable. Our existence, the stars, galaxies, and cosmic structures could all be the unfolding of a tunnel that began with a singular moment of passage, a bridge through the deepest mysteries of space-time. Could wormholes be responsible for strange missing stars is a question that stretches the imagination across the edges of astrophysics, cosmology, and the mysterious possibilities hidden within the universe, blending what we observe with what we cannot yet explain, and inviting us to consider that the disappearance of stars might not always have mundane causes, but could hint at hidden structures threading the cosmos in ways invisible to our instruments. Astronomers have cataloged countless stars across galaxies, mapping their motions, brightness, and life cycles. And yet some stars appear to vanish without the expected explosion of a supernova, fading from sight in ways that defy conventional explanation. Could wormholes, those hypothetical tunnels through the fabric of space-time, provide a path for stars to leave our observable universe, slipping into regions beyond detection, into distant galaxies, or even into entirely separate universes? Imagine a massive star, perhaps several times the mass of our Sun, reaching the end of its life. In ordinary circumstances, it would collapse into a black hole or explode as a supernova, releasing vast amounts of energy and matter that illuminate surrounding space. Yet, in some observations, stars seem to fade quietly, leaving no remnants, no explosion, no detectable debris. If a wormhole were nearby, a structure formed of exotic matter that threads space-time and resists collapse, the star could theoretically be pulled into the tunnel, disappearing from our local universe entirely. The entrance of the wormhole could remain invisible, its exotic matter preventing light from escaping in normal ways, bending space-time so subtly that even gravitational lensing might not reveal its presence. To us, the star is gone without trace, its disappearance a cosmic mystery, but in reality, it may have simply traversed a hidden corridor in the universe. The physics of such an event is extraordinary. Wormholes, as solutions to Einstein's equations of general relativity, require regions of negative energy density or exotic matter to remain stable and open. A massive star approaching such a wormhole could generate extreme gravitational interactions, its mass interacting with the curvature of space-time around the tunnel entrance. Tidal forces might stretch the star, yet the exotic matter could stabilize the passage, allowing the star to pass through intact. or at least partially intact, while bending light and gravitational waves in ways that prevent detection. The process could take minutes, years, or millennia from the star's perspective. Yet to observers across the galaxy, it may appear as though the star vanished instantaneously. Visualize the journey. As the star approaches the wormhole, the surrounding light could distort, stars in nearby space stretching or twisting as the fabric of space-time is warped. Gravitational waves might ripple outward, too faint or misaligned for our instruments to detect. Matter from the star could begin to experience unusual accelerations, the outer layers subtly drawn toward the tunnel while the core remains relatively stable. From a distance, the star simply dims, fading against the backdrop of its galaxy until it is no longer visible, leaving astronomers puzzled. The path it takes is not through ordinary space, but along a corridor where distance, time, and direction are fundamentally altered, perhaps connecting to another galaxy, a distant part of our universe, or a parallel universe entirely. The implications for observation are profound. If wormholes can transport stars, they might also move clusters, gas clouds, or even entire regions of galaxies, creating anomalies in galactic structure that are difficult to explain through conventional astrophysics. Dark matter, already elusive and only inferred through gravitational effects, could interact subtly with these wormholes, influencing their stability or guiding the trajectories of stars into hidden tunnels. The universe we observe might be only a fraction of the cosmic activity occurring, with some matter slipping silently into corridors that our instruments cannot probe. The distribution of missing stars, their locations, and the subtle effects on nearby gravitational fields could offer indirect hints, but the full picture remains hidden. The psychological and philosophical implications are staggering. The stars we see in the night sky, twinkling across vast distances, might not be permanent fixtures, but travelers on invisible pathways. A star that vanishes from our galaxy could reappear elsewhere, or never be seen again, reshaping our understanding of permanence, distance, and connection in the cosmos. The night sky is not just a map of the present universe, but a dynamic, shifting landscape, with hidden tunnels, missing stars, and invisible networks threading the heavens in ways we can only begin to imagine. Even more speculative, wormholes could explain other anomalies observed in stellar behavior. Stars appearing younger or older than expected, sudden brightening or dimming without clear cause, or peculiar motion inconsistent with local gravitational forces might all be influenced by interactions with hidden space-time tunnels. Exotic matter stabilizing a wormhole could subtly affect surrounding gravitational fields, guiding nearby stars or bending their light in ways that create optical illusions, apparent disappearance, or movement along trajectories impossible under normal physics. Astronomers might interpret these signals as unusual phenomena within the observable universe, while in reality, they could be the subtle fingerprints of hidden passages threading the cosmic fabric. Traveling through a wormhole, a star could emerge in a galaxy far across the observable universe, perhaps billions of light-years away, appearing in a new location without the expected supernova or remnant. Or it could emerge in a separate universe entirely, part of a multiverse in which each universe is connected through a hidden network of tunnels, pathways invisible to ordinary observation. The missing star could continue its life, unaware of the passage, while observers in the original galaxy are left with a cosmic mystery, a puzzle that challenges the boundaries of understanding and suggests that the universe is far more interconnected and dynamic than it appears. The energy, light, and gravitational interactions involved in such processes might leave subtle traces, tiny ripples in space-time, faint distortions in the light of neighboring stars, or anomalies in the distribution of gas and dust. But detecting these would require instruments of extraordinary sensitivity and insight, far beyond current capabilities. Many of the stars we consider missing might simply have passed through wormholes we cannot detect, leaving no direct evidence, a silent, invisible reshaping of the cosmos, a hidden dance of matter across corridors threaded through the fabric of space-time. Ultimately, the idea that wormholes could be responsible for strange missing stars forces us to reconsider the nature of the universe itself. The cosmos may not be a fixed map of galaxies and stars, but a dynamic, shifting tapestry with hidden pathways, invisible tunnels, and matter moving along routes beyond ordinary detection. Some stars disappear not because they die or explode, but because they travel along corridors invisible to our instruments, weaving through the hidden architecture of space-time. The universe may be far more mysterious, connected, and wondrous than we perceive, with wormholes silently threading reality and carrying stars away into the unknown. Could wormholes explain the shape of time is a question that immediately stretches our imagination beyond the familiar linear progression of past, present, and future, inviting us to consider that time, like space, might have hidden tunnels, folds, and shortcuts that warp, twist, and bend its apparent flow, and that the universe itself may be threaded with structures that subtly shape how events unfold, memories persist, and causality is experienced. In ordinary human experience, time feels like a straight line, moving inexorably forward from the past, through the present, and into the future. Clocks tick, stars age, and planets orbit in a rhythm that seems continuous, predictable, and linear. Yet, theoretical physics, particularly the study of wormholes, general relativity, and quantum mechanics, suggests that time may be far more malleable than our everyday senses reveal, and wormholes could be a hidden factor in the very geometry of temporal flow. A wormhole, at its core, is a bridge between different regions of space-time. If it is possible for a wormhole to connect 2 points in space, it may also connect 2 points in time, allowing paths that curve backward, loop, or stretch across epochs. Imagine a tunnel where one end exists in what we perceive as the present, while the other end emerges in a distant past or far future. Matter, light, and information passing through such a tunnel would carry temporal signatures, essentially traveling through a corridor that allows events to leap forward or backward along the timeline. This bending of time could ripple outward, affecting surrounding regions of space-time, subtly warping the perceived progression of events, and creating the impression that time has a shape, curvature, or even folds that are invisible yet real. To visualize this, consider the universe as a vast sheet of space-time, smooth in most regions but dotted with extraordinary distortions. Wormholes act as tunnels through this sheet, linking distant points not only across space but along the temporal axis. An object entering a wormhole might emerge in a location separated by billions of years, appearing younger or older than it should, carrying the evidence of its journey in the form of altered motion, energy, or quantum state. The cumulative effect of many such wormholes, perhaps scattered invisibly across galaxies and between universes, could create a hidden scaffolding in which time is not a simple arrow, but a network of curves, loops, and shortcuts, a topology of moments that underlies the apparent linearity we observe. The physical sensations associated with such a temporal geometry would be extraordinary. If a human or a probe were to pass through a time-influencing wormhole, perception itself might warp. Moments could stretch or compress, seconds dilating into hours, or centuries collapsing into a single heartbeat. Light entering the tunnel might bend and refract unpredictably, revealing glimpses of past events as though time itself were layered and visible. Gravitational effects could further distort temporal perception, with regions near the tunnel entrance experiencing time differently than regions near the exit, producing a paradoxical feeling of being simultaneously present in multiple eras, a sense of standing on the intersection of past, present, and future. The implications for causality are profound. If wormholes allow connections between different times, the universe could host a subtle web of influences in which events are not strictly sequential but interconnected across epochs. Actions in one location could reverberate into the past or future, with energy, matter, or information propagating along hidden corridors. This does not necessarily imply contradictions or paradoxes, because the geometry of space-time could enforce consistency, but it does suggest that time itself is shaped not only by the expansion of the universe, entropy, and physical laws, but also by the hidden presence of tunnels that thread reality, subtly guiding the flow of events and the experience of change. Furthermore, wormholes could explain some of the strange phenomena observed in cosmology and quantum physics. Temporal correlations, unusual alignments of distant galaxies, and the apparent synchronization of events across vast cosmic distances might reflect the influence of hidden space-time tunnels. Quantum entanglement, in which particles share instantaneous connections across space, could even be influenced by microscopic wormholes threading the quantum fabric, creating shortcuts that shape correlations in ways that suggest a hidden architecture of time itself. The universe, in this view, is not merely a stage upon which events unfold sequentially, but a living structure where time is sculpted, curved, and connected by unseen passages. Emotionally and philosophically, the idea transforms our understanding of existence. Time is not merely something that flows around us, but something we inhabit, a shape we move through, a landscape molded by hidden tunnels that bend, stretch, and link moments across the cosmos. Past, present, and future are not fixed, but flexible, woven into a network shaped by wormholes that may connect galaxies, universes, and dimensions in ways entirely beyond ordinary perception. Every memory, every moment of consciousness, every ripple of energy could be subtly influenced by the hidden architecture of temporal tunnels threading reality, suggesting that our experience of time is both personal and cosmically connected. The visual and sensory experience of such wormhole-influenced time would be remarkable. One might see echoes of the past layered over the present, stars appearing as if moving backward, galaxies shifting in unexpected ways, light bending in curves that reveal hidden moments. Traveling through one of these tunnels could feel like stepping into a kaleidoscope of eras, each moment unfolding simultaneously, a continuum of perception where the boundaries between now, then, and later dissolve. Colors, motion, and light could carry information not only about space but about when events occurred, allowing a traveler to witness the history and potential future of the cosmos in a single, continuous experience. Even on a practical scale, wormholes shaping time could have subtle consequences for the universe's evolution. The formation of galaxies, stars, and planetary systems might be influenced by hidden temporal shortcuts, creating alignments and structures that would otherwise seem improbable. Gravitational interactions could ripple through the temporal web, guiding matter in ways that produce the large-scale cosmic patterns we observe. The cosmic microwave background, the afterglow of the early universe, might contain subtle fingerprints of these temporal distortions, encoded in fluctuations and variations that hint at hidden corridors, linking moments across billions of years. Ultimately, the idea that wormholes could explain the shape of time invites us to see reality in a profoundly interconnected way. Time is not merely a river flowing from past to future, but a tapestry threaded with tunnels, shortcuts, and folds, a network of moments shaped by structures hidden from ordinary view. Wormholes could subtly sculpt the flow of events, link epochs across vast distances, and create a universe where past, present, and future are interwoven in ways we can barely imagine. The stars, galaxies, and quantum particles around us might all be moving along invisible pathways, experiencing a curvature of time that shapes the unfolding of reality itself, a cosmic dance guided by tunnels threading the very fabric of existence.